So, welcome to this new section on analyzing project timelines and the first lecture of that in this course, AI for Project Planning and Excellence. So, in this section, we will help you learn how can you use AI for excellence in analyzing project timeline. And in the first lecture, we will talk about predictive scheduling, where you will learn how can you use machine learning models to forecast delays based on the past performance, task dependency, and external factors, right? So let us take a look at that. So how do you think you can use machine learning models to forecast delays based on past performance, task dependency, and external factors? Any thoughts? Using machine learning to forecast delays basically involves a structured pipeline of data collection, pre-processing, model training, and deployment. And there are many steps that you need to take to build and use machine learning models to predict project delays based on the past performance, task dependency, and external factors. Let's take a look at the various steps that you need to take to be able to do that. So first obvious step is to define the problem. And there you need to define what is your goal, what is it that you want to achieve, and which could be like predicting the likelihood of a task or a project being delayed in terms of a binary, yes and no, or in terms of regression, how much delay will it happen? So you could choose one of those two goals, and your output then that you want from the machine learning model is a delay risk score, number of days delays, or simple classification. So you need to define your problem first in terms of goals and output. Then you need to collect and structure data. You need a historical data set of the past practices, and your key variables could be, past performance data that will include things like planned versus actual start and end date, historical delays per task and project, project completion rates. You then also need data on task related data. You need task durations, dependencies, the predecessor's task, task complexity or type, and assigned resources. Then you need data about resources, right? And then you need resource allocation levels, team members' experience, resource churn rate. Then there are external factors that you need to collect. You need to have weather data for construction, especially supplier performance, market volatility, holiday or strikes. And then there is metadata that you need to be mindful to collect in terms of project size, industry, location type, and budgeted versus actual cost. So there's a lot of data that you need to collect and structure to be able to build that machine learning model. Then you transform raw data into meaningful features. And what are these features that you need to do in this feature engineering stage? You have lag features. How many days prior to task was delayed? Then you have dependency scores, number and weight of dependent tasks. Then you have resource load index, resource capacity utilization, and then you have weather index, weather impact index in terms of construction lost days due to rain. And then you need task criticality, whether the task is on the critical path. Now you can use tools like network or for dependency graphs and Panda NumPy for feature processing. That's a part of feature engineering. Then you choose and train the models, right? There, what are the common algorithms that you can use? So you can use logistic regression for binary classification, whether the project is delayed or not delayed, or will be delayed or not delayed. Then you can use random forest and XGBoost that can handle non-linear interactions and feature importance. You can also use gradient boosting that works well for the time series and structured data. And finally, the most advanced LSTM or RNN, where you project timeline uh, is in a time sequential manner. So your tasks are updated over a period of time. So these are some common algorithms that you can look from. Then let's take a look at an example of random forest in Python. So you could have this kind of command coming into from sklearn and sample import random forest classifier. You import the program, then you define the model, then you fit the model, and then you make the predictions based on the data that you have had. So that's how you choose and train the models, right? The fifth step would be to evaluate the model, and there you need to evaluate using matrices such as accuracy, precision, and recall, F1 score for classification, mean absolute error in RMSE for regression delays in delay in days, and ROC-AUC for delay probability. So based on your goals and the definitions, you decide how to evaluate the model. Then you interpret results and feature importance. You use Shapley additive explanations or feature importance plots to identify which features most influences delay and which dependency or teams are the risk factors. So like this, you interpret results and feature importance. Then you start deploying and monitoring. You integrate them with the current PM tools like Jira, MS projects to get real-time updates, right? And you generate dashboards with tools like Power BI, Tableau, and Grafana, and alert managers when a task hits a certain delay probability threshold. So like this, you deploy and monitor. And let's take a look at an example of an output. Now, an output from the machine could be saying like this. Task 42 has a 87% chance of being delayed due to bottleneck in task 40, which is running 3 days late and uses the same over allocated backend team, right? And it could also say, as a second example, rain forecast next week increases project delays by 12%. So that's how this machine learning models can forecast delays based on past performance, task dependency, and external factors. So what are the tools and platforms you can use? In Python, you can use Pandas, scikit-learn, XGBoost, and SHAP. In auto ML platforms, you could use Data Robots, H2O AI, and Google Vertex AI. If for data visualization, you could use Power BI, Tableau, and Looker. And for data pipeline, you could use Apache Airflow, dbt, and SQL. So these are some of the tools and platforms that you can use. So what do we do next? So we look at another aspect of analyzing project timeline, and that is of critical path analysis, in which we will talk about how can you use AI to identify the most important tasks that could delay the project if they are not completed on time. So that's what we will do in the next lecture. So thank you so much for watching this first lecture on analyzing project timelines. I hope you continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.